Hello everyone, welcome back to our educational video. Today we are going to discuss about the point measurement of 10dq or the energy parameter or a splitting parameter delta 0. In previous video we have discussed about the crystal field theory and the splitting of d orbital or splitting of energy levels. Then in next video we have seen the point that is distortion, that is John Taylor distortion. And now in this video we will discuss about measurement of 10dq and the factors affecting this value. Now the energy gap, that is 10dq or del 0 between the T2g and EG orbital in octahedral complexes, they can be discovered or determined from the absorption spectrum of the complexes. In the transition metal complexes, the value of 10dq is usually small. The excitation of electron from the lower energy orbital to the higher energy orbital is very easy and can be achieved even by the absorption of low energy radiation present in visible light. So most of the complexes are colored because of absorption of some selected wavelength of visible light. So let us look the magnitude of del 0 that depends on or the factors which are affecting the value of separation delta 0. The first and most important factor is the size of ligand. So the increase in size of ligand ultimately decreases the value of delta. That means the size of ligand is indirectly proportional to the value of delta 0. Means as the size of ligand increases, the value of delta decreases, or as the value of delta increases, size of ligand decreases. So if you look into the halogens, that is fluoro, chloro, bromo and iodo, then the value of delta is increases or the size of ligand increases, and ultimately the value of delta is decreases. Means the fluoro is the first and most important ligand of the periodic table, so the size of this fluoro is smaller as compared to the chloro, as compared to the bromo and as compared to the iodo. Means the size of iodo is larger than all these three. Means size of ligand is increases as we move from fluoro to iodo, but the value of delta is higher of in fluoro, then lower in chloro, then lower in bromo, and lastly very much low in iodo. So this is how the value of delta 0 changes as the size of ligand changes. Now the second and most important factor is number of couples in a signal. Increase the number of individual couple increases the non-centralization and decreases the value of value of delta. Means the number of individual couple is increases as in the complex, then this is showing the uh, indirect proportionality towards the decrease the value of delta. If you look here, the first complex or first complex is the NH3 coordinated to the metal, and the second is H2O, and the last is fluorine. So if you look here, the first in first figure or in first structure, the number of individual couple is lower. Then in second, the number of individual couple in H2 is smaller, and in fluoro again the number of couple in fluoro is the higher, but here the value of delta is lower in first structure, then again it is lower in second structure, and lowest in fluoro. So as here the number of individual couple increases, the decrease in the value of delta 0. So this is showing the indirect proportionality between these two. The greater the number of individual couple, lesser is the energy. Then the third important factor is the nature of the ligand. So the value of delta 0 increases with the strong ligand more than with the weak ligand. So if you look into the nature of ligand, then there are only two types of ligand, that is the weak ligand and strong ligand. So if you look into the value of delta 0, So the value of delta 0 is increases with the strong ligand but decreases with the weak ligand. Now the fourth factor is the change oxidation state, charge or oxidation state on the metal. So delta 0, that is the value of delta 0, increases as the charge increases. Here the directly proportionality is there between the charge and the value of delta 0. More oxidation increased as the power of attraction between the ion central groups coordination increases, and this lead to the increase in value of delta 0. For example, there are two complexes given here in front of you. Rubidium metal ion is there and water molecule is here as a hexadentate ligand. So both the difference between both of these complex is the charge only. The first complex is having 2 plus charge and the second complex is having 3 plus charge. And if you see, the value of delta 0 is 19,800 per centimeter in the first complex and 28,600 per centimeter in the second complex. That means the charge is lower, then the value of delta 0 is also lower, and if charge is greater, then the value of delta 0 is also greater. So this is showing that the directly proportionality between the charge or oxidation state towards the value of delta 0. So as delta 0 increases, as the oxidation state increases. So higher oxidation state, the less size of the central atom and approaching the group giving to the central atom are larger, and so increase the value of delta. Now the fifth factor is the whether the metal is in first, second or third row of transition element. So here the delta 0 increases between the adjacent member down a group. Means the value of delta 0 is increases as we move from 3d orbital to 4d orbital to 5d orbital. Increase the value of d orbital, the delta 0 value is also increases. So this is also a directly proportionality between the d orbital value and the delta 0 value. As the value of delta 0 increases, the d orbital also increases, or as the value of d orbital increases, value of delta 0 is also increases. Now what is the reason that the cobalt complexes both are having same hexadentate ammonia ligand but different charges are there? First is 2 plus, then second is 3 plus. So 2 plus charge or complex showing paramagnetic structure but 3 plus complex showing diamagnetic structure. Then what is the reason behind this? Now let us look here. The delta 0 value of the second complex, that is having 3 plus charge, is greater than the second complex which is having 2 plus charge, because where the charge is increases, the value of delta 0 is also increases. We have seen it before. So here the delta 0 in 3 plus charge molecule or complex having greater value than the 2 plus charge complex. This is because coordination group can approach more to the metal ion small with the high charge and thus can interact more strongly with the d orbitals. Now if you look here in the molecular orbital diagram, then you will see here the first complex, which is a cobalt NH362 plus. Here the value of delta 0 is lower, means there is a less difference between the highest energy orbital energy level or lowest energy level. And also if you look into the electron, then at the lower energy level there are two paired electron and one unpaired electron, and at the highest energy level there are two unpaired electrons. So this means there are three unpaired electrons in this complex. So ultimately this is a paramagnetic structure. And if you see the second complex, that is cobalt NH363 plus, here the value of delta 0 is larger than the first complex. That is, the difference between lower energy level and higher energy level is larger. And also if you look into the pairing of electrons, then all electrons are there in only lower energy level, because too much gap is there, so electron excitation is quite possible. So all the electrons are paired, that's why it is diamagnetic structure. Now tetrahedral complexes are favored by first large and bulky ligand, second wherever attainment of a regular shape is importance, D0, D2, D5, D7 and D10 are regular shape. Then they are also favored by weak field ligand. Then where the central metal has a low oxidation state, they are favored where the electronic configuration of the central metal D0, D5, D10, as there is no CFSE, that is crystal field splitting energy. And they are also favored where the loss of CFSE is small, as in the D1, D2, D6, D7. Now here we found from the CFT that the value of delta 0 in case of complex tetrahedral less than 50% of the value of delta in case of complex octahedral if all other things are equal. So therefore we can conclude here delta T means the value of delta in tetrahedral complexes is equal to 4/9 times of delta O means value of delta in octahedral complexes. Delta T is showing for tetrahedral complexes and delta O showing for octahedral complexes. So here the relationship between the delta T and delta 0 is given, that is delta T is equal to 4/9 times of delta O. Now the reason for delta T is equal to 4/9 times of delta O are the first, there are 4 ligand instead of 6. The ligand field is 4 6, that is 2/3, right? In tetrahedral complexes there are 4 ligand and in octahedral complexes there are 6 ligand. So there is a difference between the ligand number of ligand, and that is 2/3. Then second is in tetrahedral, the direction of the orbital does coincide with the direction of the ligand. Not this reduces the crystal field splitting by roughly, that is a further 2/3, and thus delta T is equal to 2/3 into 2/3 is equal to 4/9. So this is the reason that delta T is equal to 4/9 of times of delta O. If the size of large ligand preferred composition of complex tetrahedral, if the size of a small ligand preferred octahedral, then here in diagram you can see cobalt I4 2 minus and or cobalt Cl4 2 minus, the tetrahedral structure. The metal atom is at the center and the 4 ligands are there in square planar form. And in octahedral structure, if you look here, the cobalt F6 3 minus, then here cobalt is at the metal atom at the central, and 6 fluoro ligands are there in octahedral shape. So if the size of large ligand preferred composition of complex is tetrahedral, right? And if the size of small ligand is preferred, then the composition is octahedral. Now, whenever the difference in the value of delta 0 between the octahedral and tetrahedral is large, then prefer the formation of octahedral shape, that is D3 and D8. No vehicles finally did not separate until now chromium 3 in the tetrahedral, but would prefer chromium 3 octahedral of a CrH2O6 3+, because in case of D3 the difference in the value of delta between the octahedral and tetrahedral of a large, while that whenever the distance between the values of delta a small tetrahedral preferred in case of D0, D5, D10, select any of them depending on the circumstances of the experiment. In the case of Mn2 plus, we find when you add a large amount of ligand be an octahedral, that is MnH2O6 2 plus. So this is how we have successfully completed the parameter, energy parameter, that is delta O in octahedral complexes as well as tetrahedral complexes. So we have also seen the relationship between the energy parameter delta T in tetrahedral complexes and delta O that is octahedral complexes. Also, we have seen the factor affecting on this energy parameter. So I hope you must understand our today's topic. We will meet in next video with new topic. Till then, thank you and bye bye.